logistics. Today's webinar is based on a full report by the Pacific Northwest National Laboratory, and you can find the full report as well as a one-page infographic and four-page report summary at gsa.gov/GPG. After today's webinar, the recording as well as the presentation slides will also be available at gsa.gov/GPG under Outbrief webinars. You can also find a schedule for upcoming webinars as well as a link to subscribe to our GPG mailing list if you haven't been getting any of the webinar announcements. Today's webinar is one in a series, and our next webinar will be on October 11th on a soon-to-be-released evaluation on small circulator pumps with automated control. These small circulator pumps, less than 2.5 horsepower, are numerous in U.S. commercial buildings. It's estimated that there are more than 30 million of them, but they've typically been overlooked for efficiency upgrades because it can be expensive to switch these small pumps to variable speed drives. This new technology provides the variable speed capability at a lower cost and with estimated savings greater than 50%. We'll hope you'll be able to join us on next month's webinar. Today's webinar and all GPG webinars offer continuing education learning units through the American Institute of Architects. To receive credit, please complete the post-webinar survey, which you should receive shortly after today's webinar, though it looks like we're having some issues with the email delivery from our webinar program, so that survey may be delayed. But if you don't receive the survey within the next hour or so, please reach out to Michael Hobson. During today's webinar, participants are set to listen only, but you can submit questions by using the chat box on the lower right of your screen. And you don't need to wait until the Q&A session to submit questions. In fact, we encourage you to submit them well in advance of the Q&A. So thank you again for joining us, and I'll turn it over now to Mike Lowell, who will be facilitating today's webinar.
Thank you, Andrea. Next slide, please. Welcome, everyone, to today's webinar, and thank you for coming. First, we'll start off with an introduction to GSA's Emerging Building Technologies program by Kevin Powell, our director. And next, we'll follow up with the actual presentation on the report from Srinivas from Pacific Northwest National Laboratory. And then we'll get some on-the-ground feedback from Frank Campagna and Stuart Lampkin of Region 7, where this technology was installed and tested. And finally, as Andrea said, we'll follow up with a Q&A. And that will be the end of our presentation. Next slide. And with that, I'm going to turn it over to Kevin Powell. Kevin, you might be on mute. And Kevin, you're still on mute.
Oh, hello, can you hear me now?
Yes.
Okay, I think I was muted there, sorry. Okay, so next slide, please. Since everybody now will know what I look like, good, thank you. So just a couple of quick notes about our program. Our program was stood up about 7 years ago at this point. The idea is to provide a one-stop shop, a central point in GSA to look at technologies that are essentially the best of what's next. The idea is these technologies have demonstrated some sort of merit in any of a number of different kinds of ways, but we don't really know whether or not they can deliver in the real-world operating environment, which is, of course, what we need them to be doing. So the program goes, and this is what you'll be hearing about. We identify these technologies, we select the best of the best, and then we install those technologies in a testbed location, have a national lab evaluate, and then at the end of the day, if they truly do deliver, we have a second program that's called Pilot to Portfolio that looks to deploy those successful technologies, those technologies with a successful field demonstration broadly. And with that, I will turn this over. So next slide. Actually, Andrea, I'm unsure. Is this slide for me?
It is for you, Kevin. Yes. If you could want to introduce kind of the partnership, that'd be great.
Okay. Thanks. I'm sorry about that. So yeah, this is a great slide, and I think it's a really interesting story, not just in terms of our partnership with Department of Energy, which includes our relationship with the national labs, but also with identifying where there are opportunities to spur innovation in the marketplace around those opportunities, and then of course to advance those into the world of our buildings. So in this case, Department of Energy's Building Technologies Office, who we've been working with for quite a number of years, developed a specification for a high-performance RTU, and this is based not so much on the federal inventory, that is to say our GSA inventory. We have some RTUs. They're not a dominant portion of our HVAC. But out there in the broader commercial world, they are. This is the dominant way that buildings are in fact heated and cooled. So we collectively said this would be a great thing to sort of develop a better, basically a step change in performance. There was a lot of research that went into why that could occur, why that could occur cost effectively. We put that out to the market, and really within 2 years, we ended up with a manufacturer, Daikin, that actually was able to meet that aggressive spec. So again, 30%, I think the spec was like 30+% better than basically the state of the then ART. So Daikin met that, they met that challenge. We then identified a test bed location. Actually, there were a number of both commercial and federal locations identified, and we identified one in Fort Worth, Texas. That's going to be the subject, or the focus anyway, of this outbrief. Next slide. Turn it over to Srinivas.
Yeah, good morning. I have a little bit of a cold, and I hope I'm coming through okay, and I'll try and get through this without major hiccups. Next slide, please. So as you heard, we're going to talk about these high-performance commercial RTUs, and we'll define what we mean by that. Now, one thing I want to make sure is this presentation uses, specific product names. However, it shouldn't be viewed as an endorsement of the product by me or Pacific Northwest National Lab, and certainly not Department of Energy. Next slide. So, as most of you know, these packaged rooftop units are ubiquitous, and they're used to condition nearly 50% of all commercial floor space in the U.S. The popularity comes because they're easy to install and relatively low first cost. However, many of the existing units in the field have relatively low seasonal energy efficiency, because they were built with constant speed drives and without advanced controls to better coordinate economizer and ventilation operation, and also part load operations. So as you heard from Kevin, in 2001, to stimulate the market with higher performance units, Department of Energy Building Technologies Office issued a challenge to manufacturers to build a unit that is 50% more efficient, based on IEER. And IEER is basically an integrated energy efficiency ratio. It could be viewed as a seasonal efficiency measure, as opposed to energy efficiency ratio, which is a measure of efficiency at a single indoor and outdoor condition. So the first RTU compliant unit was introduced in the market in late 2012 to 2013. Currently, there are a number of manufacturers who have products that meet the RTU challenge specification. And as you seen in the previous slide, Daikin was the first one to introduce that. This presentation will describe the major features of high-performance units and the results from the field of one particular unit. Next slide, please. So there are basically two variations of the high-performance RTUs, the way that we define it. The first and most commonly used high-performance RTU sold in the market today, couples a variable speed drive with a supply fan motor. And some of these units also have variable speed drives on the outdoor fan motors. There's at least one manufacturer in the US that actually sells all variable speed. That means the supply fans are variable speed, the outdoor fans are variable speed, as well as the compressor. So it's the one that you see on the right there. So most of these high-performance units modulate supply fan speed to meet a specific zone dry bulb temperature. So that's the supply fan modulation. And the units that have variable speed compressors, they modulate the compressor speed to maintain a certain discharge air temperature. Next slide, please. So, the unit that you're seeing here is the one that was tested. This unit actually uses electronically commuted motors for fans. And then it also has a variable speed drive on the compressor motor. So these high performance units, especially the ones that are, 7.5 ton or larger, may have multiple compressors. For example, a 7.5 ton unit might have a 3 ton and a 4.5 ton capacity, which allows these units to have 3 distinct capacities. 3 ton when only one first compressor is running, 4.5 ton when the second compressor is running, and then a 7.5 ton when all of them are running, right? So when you have a unit that has a variable speed drive and multiple compressors, only one of the compressors is actually variable speed, and the rest of them are usually constant speed. Next slide, please. So, I'm going to cover, how we did measurement and verification. We actually did 2 different sites, and this presentation mostly will be based on the site that we did in Fort Worth, the one on the right that you see here, although we will present some results from the supermarket site in Florida as well. So ideally, when you're conducting a measurement and verification process to estimate savings from a retrofit, you want to measure the performance of the existing unit for a period of time, typically 9 months or longer, then replace that existing unit with a new unit. And then develop a model for the unit that you replaced using the monitored data, right? And then you measure the performance of the new unit. So you would then compare the expected performance of the unit that was replaced, that's the old unit, using the model, and then the actual performance of the new unit that you're continuing to monitor in the field. So, however, this approach takes twice as long to complete and also requires more resources. We didn't have either of them. So we used an alternate approach to verify the performance of these new high-performance units and compared them to existing standard units. So the alternate approach was reasonable, provides reasonable results if you're trying to compare efficiencies of 2 units. So that's what we did, basically simultaneously measure the performance. So next slide, please. So, the measurement that we did was simultaneously for over a 10-month period involved simultaneous monitoring of an existing standard unit and the high-performance unit that was shown previously. And then the the measurement plan or measurement sensors are shown in the slide on this here, right? So in addition to this, the temperature and relative humidity measurements, we also measure the airflow. For the standard unit, which has a constant speed supply fan, we did one-time characterization of the airflow to measure what the airflow is in the as installed condition. And then for the high performance unit, because the unit modulates the supply fan, so we basically did a one-time measurement of the fan flow as a function of fan speed, because we cannot measure fan flow or airflow continuously in the field. So, but we can measure the speed of the fan. So if we can correlate the speed with the flow, then we know what the flow is at any given speed. So we did that one time. And then this allowed us to estimate the cooling load on the coil. And we also measured the total energy consumed by the unit, which allowed us to estimate the installed energy efficiency ratio for the both units. Next slide, please. So we did this, as I said, over a 10-month period. You know, the graph that you see here is essentially daily energy efficiency ratio as a function of outdoor temperature. So the daily energy efficiency ratio, which is basically a ratio of total cooling provided by the unit over the course of a day to the total energy consumed by the unit, kilowatt hours, over the course of the day. So on average, the high performance unit was about 16% more efficient than the standard unit, at least in this comparison. Next slide, please. So, you know, comparison of, and before we actually did the field tests, we also did a lot of simulation analysis to estimate what the potential savings would be across the nation. You know, comparing the results from simulations to actual field performance is always a bit tricky, because simulation models are always ideal and don't reflect the true field conditions. You know, however, the simulations serve a purpose, you know, to provide some qualitative comparisons between two alternate designs. And some of the differences that you find between simulation and field tests are because, you know, the two units that we tested serve different loads, whereas in simulation they serve the same load. And then there was also differences of EER of the standard unit. In the field, it was 11.4, which was slightly higher than what was used in simulation. So these, all of these lend to some differences in estimate of simulated savings versus what we saw in the field. We saw a savings of 26%. This is, you know, the 16% number you saw was in the difference in the seasonal energy efficiency ratio. But in terms of energy, it was 26% reduction of energy for the high performance unit compared to the standard unit. The simulations predicted it would probably be around 40% for that climate location and for that type of building. Next slide, please. And I'm going to cover some of the installation details, and you'll probably hear more from our GSA staff from that building, additional details. You know, each installation is going to be different. So, however, there are a few things that you can consider while if you're considering these type of units. The challenge units are generally heavier than the units that you're replacing, and may also have a different footprint than the legacy units. So you need to be aware of that. Because the high performance units have advanced controllers, and some of the installers may not be familiar with commissioning, and it could be a little bit tricky or a bit of a challenge. However, you know, widespread deployment of these units should alleviate this issue over time. Installation may sometimes require changes to the ductwork as well, as had to be done in the supermarket side, but not here. Here they had to reinforce the roofs and you'll hear more about that a little later. Next slide, please. Okay. These results are, the payback results are from another site. We couldn't compute that at this site because we just didn't have a handle of the total installation cost because there were major modifications for the roof that had to be done. So, but we were able to do that for the other site, and based on the measurement of data over a 12-month period, we estimated that the simple payback was approximately 3.8 years. The incremental cost that we reported, that was reported by the building owner for this site, was approximately $6,000, as you can see. However, this cost could vary depending on site-specific conditions and needs. So you need to be aware of that. In some regions of the country, the high-performance units may be eligible for utility rebate. If that is the case, the payback might even be lower. So in this particular case, there wasn't any incentive. Next slide, please. So if you're considering installing these units, the best time to do that is when an existing unit reaches its end of life. So replacing a unit that has reached end of life with high performance units should be an option. And high performance units are also an option for new construction if you're building a brand new building. So modeling shows savings are greater in hot and humid climates. Also, units with variable speed compressors may provide better humidity control and comfort. Next slide, please. So if your unit it's not at the end of the life, there's also another solution, what we call this advanced rooftop controller. So let's say your unit is maybe 5 or 10 years old, and this advanced rooftop unit controller is an option, where a variable speed drive is installed on a supply and fan motor, and a controller is also installed to manage the economizer and ventilation operations more efficiently. We've done an exhaustive field test of these units. From there, we typically found that the larger units, maybe greater than 5 tons, that run for longer periods of time over day, maybe 10 hours or longer, typically have paybacks less than 3 years. The cost information that you see in here is from a report that we did maybe 5 years ago. So these are a little bit dated, and I'm sure the costs are probably lower than what we show now, show in this slide. So that's something that you need to be aware of also. It's also worth noting that the business cases have been made for installing these systems, even in low utility cost areas, such as in Pacific Northwest, where I am. And then also these high performance, just like the high performance units, many utilities also provide rebates to install these advanced rooftop unit controllers. So next slide, please. I think this is my last slide before I turn it over. If you want to do a comparison of 2 different rooftop units, we do have a RTU comparison calculator, which shown on the slide, where you can compare the performance of 2 alternatives. However, there are some restrictions. This only does cooling mode only. It doesn't include heating mode. And then it doesn't have smaller units, the residential size units. So note that this website hasn't been updated for several years now, and currently is not being supported by either PNNL or DOE. So there's no technical support if you have any questions on this. However, it's still a useful tool if you know how to use it. And it's not that difficult. If you just play with it, you'll probably be able to learn how to use that quickly. So that's all I have, and I'll wait for the questions after everyone makes their presentation. Thank you.
And
then why don't we
Frank
start?
Stuart, yeah, thanks, Mike. If you want to introduce
Okay, go ahead. So,
Fort Worth team.
Frank, why don't Andrea, are Frank's slides next?
Yes.
Yes. So thank you, Frank, Stuart, and Philippe for joining us. And we'll be receiving feedback from the three of them, and Frank will start off. Next slide.
Yeah, good morning, everybody. This is Frank Campagna with GSA Region 7 Energy and Sustainability Branch. I'm in beautiful downtown Dallas today and not Fort Worth, but I'm close enough. The only thing I really want to point out about this project is the weight of the unit itself, and that was probably the biggest challenge that we ran into right from the start. This unit weighs approximately 1,400 tons, and the existing ream only weighed 750, so we knew we had to address that situation. We got with our structural engineers, and we, as a result, they encouraged us to get an A&E involved and get a design put together so that we can reinforce this roof. So what is a one-for-one replacement turned into kind of a roofing project, for lack of a better description. It lengthened the project considerably. Probably, by the time you had your design done and you went into construction, it probably delayed everything about a month and a half. But it was definitely needed, and as you can see here with the drawing, there was a lot of steel installed to accommodate that new weight. Next slide, please. Yeah, and we invited Stuart to come in because Stuart was at the time the building manager. But before I let Stuart talk, I just wanted to say we also invited Felipe, who was our integrator. That was probably the other biggest challenge that we had in regards to monitoring the measurement and verification process. We used our Tritium-based building automation system to collect the data. And so Felipe, who is hired by our GC to do the integration, was very helpful in getting all the new points that the new system supplied. And I don't think, Felipe, that you really had too many challenges, but I know that there were a lot more points than what the old ream had, and that's always very beneficial regarding the people who actually run the building. The more monitoring and the more sensors and the more information, of course, helps them, and that's what that new Daikin unit provided. So, Felipe, did you want to add anything to that?
No, sir. I mean, the integration was pretty simple. The only challenges for the operator will be how many points, like you mentioned already, how many points they want to really see out of that integration. Other than that, I mean, the integration was very simple.
Thank you. And I know there were some issues with some of the local controls inside the unit that we had to get the Daikin people to come out and help us out, and they were very, very quick to respond, and we had a good partnership there. Thank you, Felipe. Stuart, do you want to talk about the maintenance issues? I know you were the building manager working with the local facility maintenance people. Would you like to share some of those, what's gone on with that unit over the last 2 or 3 years? Stuart, are you on mute? Well, I'll speak for Stuart. I know Stuart works in my department now, so we interact quite a bit, and he was telling me that he reached out recently to the building maintenance people, and I think with the exception of 2 minor glitches over the last 3 years, that unit has been running flawlessly. So I think by and large, everyone's very happy with the way the unit is performing. So Really don't have much more to say about the construction side of it. It was basically a one-for-one replacement if you take out the roofing project. Obviously, it's always a good idea to have all these things assessed prior to go to the construction. So, Andrea, I really don't have much else to say.
Thank you, Frank. And Stuart, I don't know if we can hear you now, if you have anything else you'd like to add.
Yeah, sorry about that. I had to call back in.
No problem.
This is Stuart Lampkin. And so I was a property manager during this project. I've since become a project manager underneath Frank. But really, it was a pretty smooth project other than the roof work. After the unit was installed, like Frank mentioned, there wasn't really any issues operation or maintenance-wise. It's been running like it should and no issues.
Great. Thank you. And with that, we'll turn it over to you, Michael, to facilitate our Q&A. And please, if you have any additional questions, submit them in the right-hand corner of the chat window.
Okay, thank you, everyone. And let's start with question number 1. And what I'll be doing is I'll be referring these questions to whoever I think is the likely person to answer the question. Most often, Srinivas, that will be you. But Richard asked, for everyone's info, here's a link to the document that was prepared on the, it's just reference. So I encourage everyone to look at Richard's reference that he offered in the chat. It gives more information about cooling equipment. Brian asked, did any other manufacturers meet the RTU challenge? I believe in the presentation, Srinivas said that several other manufacturers, subsequent to Daikin being the first, did meet the RTU challenge specifications. Richard asks, how many RTUs are running in the U.S.? Srinivas, I don't know if you have access to those kinds of numbers. You might be on mute, Srinivas, if you were going to respond. Srinivas, are you on mute? Oh, well, I'm going to move on. I'm going to guess that we don't personally have numbers on that, but we can look into that. Ditmar asks, and I'm hoping, Srinivas, you can respond to this. Ditmar asks, why did we compare EER instead of comparing IEER? I'm switching screens on Raya. Is Srinivas still on?
Yeah, so we are, but we can't hear you, Srinivas. Can you, it doesn't look like you're muted. Let's see, can you speak up? Let's see if we can try and hear you. If not, maybe you want to call back in. Okay, I think we might need, well, maybe have to have him call, Srinivas to call back in because we are not, looks like he's doing that now.
Let's see, I'm going to try to address questions that can be answered by someone else, so let me jump around here. I'm going to actually share some other thoughts that people shared. Gary mentions, I'm sorry, Srinivas?
Yeah, can you hear me now?
Yes, we can. Great.
Oh,
I
don't know what happened. I didn't do anything. Yeah, I got the first one. So all I can tell you is that AHRI publishes the new units that are sold, but it's really hard to estimate how many RTUs are actually in the field. That's kind of a hard thing. But there are some proprietary data sources that might give that answer, but I don't have access to any of those.
Okay. And then, Srinivas, the next question is, why did we compare EER instead of comparing IEER?
Yeah, good question. So EER is actually measured at one condition. It's typically 95 degrees outdoor, 80 degrees indoor, and 50% relative humidity indoors. So that has been the metric for a long time. However, that really doesn't capture the seasonal performance of the unit, because remember, a lot of these units actually don't operate at 95 degrees outdoors every day. They're operating at part load condition. So there was a new metric, just like the seasonal energy efficiency ratio for residential units. For commercial units, it's integrated energy efficiency ratio. It's basically a performance that is measured at 4 different points and then averaged. And that's a better metric that would give you a better sense of what the unit is performing or on an annual basis. So that's the reason why they chose IER rather than EER. And the current manufacturing standard requires an IER requirement as well, in addition to EER.
Okay. And then Srinivas, Gary asked, the payback does not appear to account for the structural mitigation cost. Is that correct?
Yeah. So remember, the payback that we showed was not for the Fort Worth building, but for another M&V that we did in a supermarket in Florida. There, they did not have to do any structural modifications. The existing roof could handle these high performance units without any change. So the incremental cost was basically the incremental cost for the high performance unit versus if they bought a standard unit.
Okay, thank you. And then next question is, would you please comment on the degree of noise from these RT units and any suggestions you may have to mitigate the noise issues?
Yeah, so I'll let the GSA staff answer that, but these units, because they're variable speed, they're less noisy than the traditional units. However, I'll turn over to Stuart or Frank to make a comment on what they have experienced.
Well, I'll just add, yes, they're very quiet as compared to that Ream unit. With it, running in a lower speed, it just goes without saying that there's less noise associated because of that functionality. So I would definitely agree with you.
Stuart, anything to add?
Just same thing with Frank. I concur. It's a lot quieter than the normal RTU unit.
Okay, thank you. Let's see, next item, Teresa also shared in the chat if people want to look up the link, an evaluation of a Daikin Rebel in a field test in Sacramento. And then Moniad asks, looking only at the capital costs to replace an RTU, not the incremental cost, what is the expected payback range at 10 cents a kilowatt hour?
I can tell you that the best source is if you go to the RTU change calculator and put those numbers and see. It all depends on the load on the building, type of the building, location of the building. It's hard to say.
Right. Thank you. Reginald asks, was the roof modification accounted for in the payback calculation? As we indicated before, the payback calculation that was offered in this presentation was for the Florida supermarket study, not this study. Let's see. John Beadle asked, didn't the RTU come with a controller and sensors? I believe the answer to that is yes. It's just back earlier before the RTU challenge. Srinivas confirmed this for me. Prior to the RTU challenge, there was a mechanism by which you could add controllers and sensors to RTUs, and that I think you showed a slide that shared the results from that. Yeah, correct?
So these RTU, high-performance RTUs, because they're doing a lot more controls than the standard units, they do come with controllers, and they also support integration to the existing building automation systems like we did at Fort Worth. But the older ones may or may not have a controller.
Okay, thank you. Jack asks, in your testing, did you find that the unit performed according to the rated IEER?
So repeat that again.
Jack was asking, in your testing, did you find the unit performed according to its rated IEER?
It's so IER is a a rating condition, and there are specific indoor and outdoor conditions that the tests are done. So it's really hard to do that kind of a estimate in the field for IER. What we did was basically estimated a seasonal efficiency over the monitoring period at every load that we saw. So the seasonal efficiency that we reported, you can't compare that to an IER.
Thank you. Mike, we will be sending out the slides afterwards. And then James asks, was there any, other than the roof modifications, was there any difference in installation or equipment costs between the Rebel and the Rebel RTU and the original RTU? And I would imagine, so we've got two components. Any difference in installation cost, and then is there any difference in the equipment cost?
Was that directed towards me, Mike? Or
why don't you take care of, yes, if you can answer it, that would be great.
Well, I would just say that there had to be some modifications to the ductwork, which was, a little bit of an added cost, but nothing as compared to what the roof modification cost. So it was very little to none besides a basic rooftop for rooftop replacement.
Okay, thank you. Do either you or Srinivas have any idea of the cost, just unit to unit?
I would have to go back, Mike, and look at those notes. I don't have them off the top of my head.
Okay. Okay, thanks. And then Jerry asks, how often are the RTUs running, and how often do you have to perform maintenance besides changing filters? So any maintenance differences between the Rebel unit and the incumbent unit?
Stuart, why don't you take that one?
Yeah, so this is Stuart. We'd have to look at the data to see how often it's been running. But as far as the maintenance, all they've had to do, I think the unit's been in for 2 or 3 years, but all they've had to do is the basic maintenance of changing the filters out. There hasn't been any replacements or anything that have taken place so far, other than the filters themselves.
Okay, thank you.
And I would just add, Mike, that we have these units on a schedule with our building automation system, so they don't run 24 hours a day. But in this part of the country, they do run quite a bit.
Sure. Okay, thank you. Francis asks, how does the test RTUs deal with oil fouling on the inner heat absorbing coils that will rob RTUs of cooling capacity over time?
Yeah.
Any experience with that, or?
I don't think these are any different from standard units in terms of the technology, the compressor technology and the heat exchange technology. So I'm guessing, whatever the standard units face, the high performance units probably will have similar things.
Okay, thank you. And then Jerry asks, in the testing with the economizer cycle included the energy savings calculation?
Well, in Fort Worth, it wasn't because the standard units was 100% recirculation, and also the climate is also not conducive for economizing. And in Florida, it was only economizing for a fraction of a time, during winter periods, and that just because of the weather.
Okay, thank you. And last question, Mark asks, did the space experience any room air distribution problems with the new variable speed supply fan RTU, considering the ductwork and supply diffusers were designed for a constant flow HVAC system? And Frank, that may speak to some of the ductwork modifications.
Yeah, I think the experience was a good one. I think it was improved over what the baseline unit had. In many instances, the set points were reached sooner, and the unit was able to use less energy, where the other unit was still trying to catch up and reach that set point. So I'm not sure if I'm answering your question, Mark, but I felt like the new unit used a lot less energy to get to where it needed to go.
Okay, thank you. And Andrea, that's it for the questions, so I'll turn it back over to you.
Okay, great. Thank you. Thanks for all those great questions, and thanks to the presenters. As we mentioned, this webinar is available for continuing education learning units, and to receive credit, you want to complete the short survey that you should be receiving shortly. And upon completion, you'll be getting credits. And if you don't, please reach out.